Welcome to discussion 27. In today's discussion, we'll talk about sections 5.1 and 5.2 on definite integrals. In this video, we'll focus on sigma notation. So I want to look at problem number 5 from worksheet 13, where we want to calculate the following sums. So before I give you a few minutes to try a few of these problems, I want to recall that when we write this notation, so this is the Greek letter sigma, and underneath that I'll write I equals m. At the top, I'll write n, and then to the right, I'll write a subscript I. What this means is, so the a subscript I is typically some formula that involves the variable I, and I'm going to start to plug in numbers in for the I. The first number I plug in is the m, and then I start to plug in one integer up at a time. So then I'll plug in m plus 1, and as I do that, I will add these terms. So I will sum these and then add it to, now I plug in m plus 2 and get a subscript m plus 2, and then I keep going like this, plus dot 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 plus, until I plug in the number that's written at the top, the n. Okay, so the sigma notation is a shorthand way to write a sum. So with that in mind, I want to have you try parts A, D, E, and I from this problem. Give yourself 6 minutes to try these. Pause the video in 4, 3, 2, 1, pause it and try these for about 6 minutes. All right, let's go ahead and talk about them together now. So I actually want to do part D first. So with the D, we have the sum from I equals 2 to 4 of I squared. So I am going to first plug in 2, and when we do that, we get 2 squared. Then we do the next integer up, which is 3. So we get plus, and then plug in 3, 3 squared. And then plus, now we plug the next integer up, would be 4. So 4 squared. And at that point we stop because we've reached the number that's written at the top. So if we add these, we get 29. All right, so for part A, we have the sum from I equals 1 to 3 of E. So with this, our formula doesn't have any i's in it. So this is kind of like a constant function. And when I plug in 1 into this, I'll just get E out. Then when I plug 2 into it, I still get E out. So we'll have E plus E, and then when you plug in 3, again, we get E out. And at that point, we stop because I've reached the top number, the 3. And adding these, we get 3E. And that is our answer. Okay, so before we do parts E and I want to recall some of our sigma notation formulas. So there's 3 formulas in particular I want to recall. So the first is, if we have the sum from 1 to n of I, well, this means if you plug in 1, you get 1, plus if you plug in 2, you get 2. And if you keep going like that, you'll get 3 plus dot 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 plus, then plug in the number at the top, that n. And we've seen in class that the formula for this is n times n plus 1 over 2. All right. The second formula is if we had the sum from 1 to n of I squared. If you plug in values into this, you get 1 squared plus 2 squared plus 3 squared plus dot 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 plus n squared. And we've seen the formula for this as well. This was n, kind of starts off the same as the previous one, n times n plus 1. But then there's a new term, times 2n plus 1, all over 6. We also have a formula for cubes. So with cubes, you'll get 1 cubed plus 2 cubed plus 3 cubed plus dot 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 plus n cubed. And this ends up being n times n plus 1 over 2. That whole thing squared. And of course, if you square this, this is going to be n squared times n plus 1 quantity squared over the denominator squared, which is 4. Okay, so with that in mind, let's look at part E. We have the sum from I equals 1 to 37 of I squared. So this looks like formula, the second formula that we reviewed, but our value of n is 37. And that means I can use this formula, but just plug in 37 for the n. So doing that, we get 37 times 37 plus 1 times 2 times 37 plus 1 all over 6. And if we work this out, we get 17575. Okay, so that is the idea for part E. I also get part I. So for I, we have the sum from 1 to n of I plus 2 cubed. So I want to solve this in two ways. So we'll do it one way. So with the first way, let's just try plugging in values. If we plug 1 into this, we'll get 1 plus 2 cubed, which is 3 cubed. If you plug 2 in, we'll get 4 cubed. If you keep going, you get 5 cubed plus dot 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 plus, and plugging in n, we get n plus 2 cubed. So we have a sum of cubes, and that kind of looks like this formula at the bottom where we're summing a bunch of cubes. There's a key difference though. With our sum, it's missing the terms at the front. It's missing 1 cubed and 2 cubed. So there's a way I can get around that. I could say, well, what if I were to add those terms back in and have 1 cubed plus 2 cubed plus 3 cubed plus dot 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 plus n plus 2 cubed. So what we had is this, but minus, it's missing the 1 cubed plus 2 cubed. And the nice part about doing that is this whole thing now we know how to handle. That's going to be this sum of cubes like this from I equals 1, but going up to n plus 2 of I cubed. And we can use our formula for the sum there, but instead of plugging in n, we're going to plug in n plus 2, because this goes up to n plus 2 cubed. All right, so that is going to give us n plus 2, and then plugging in n plus 2 here, we'll get n plus 2 plus that 1 over 2, that whole thing being squared, and then minus 1 cubed plus 2 cubed, that's going to be 9. Okay, and that is our answer. So this question didn't say we had to simplify it, so it'd be fine to leave it like this. So let's also do this one other way. All right, so solution 2 is going to involve the fact that we have something of the form x plus y cubed. And if you expand this, if you multiply it by itself 3 times and do a FOIL, you'll end up with x cubed plus 3x squared y plus 3xy squared plus y cubed. So if we do that with our sum, we'll end up with the sum from I equals 1 to n, and we'll get I cubed plus 6i squared plus 12i plus 8. And now we can split up this sum into pieces as the sum from 1 to n of I cubed. For the next term, I'm going to pull the 6 out in front because it's a constant. So we'll get 6 times the sum of I squared. With the next term, I'll pull the 12 out in front. So 12 times the sum of I. And the last term, we get the sum from 1 to n of 8. Okay, so I'm going to talk about how to do a couple of these terms, and the rest I'll leave for you. So this sum here just means 8 plus 8 plus 8 plus dot 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 plus 8. And we're adding that to, by itself n times. So that will give us 8n. And then I'll also do the second term. With the second term, we'll have that 6 in front times, and now we're going to use our formula for the sum of I squared when we do it from 1 to n. And we saw that that was n times n plus 1 times 2n plus 1 over 6. So for these other two sums, we could do something really similar. So from here, I am going to leave this for you.